In this lesson, we will talk about how to set up our FE model for running a simulation, specifically a static analysis, using a brake pedal. So the first thing that I'm going to do is first search in my search bar for a static analysis. And I'm going to use this. You can see that the FE model is the first half of running our static analysis. You can also find our simulation under the Simulation tab and also in our Design Analysis tab as well. So I'm going to double click and choose that FE model. We can also choose an FE solid model, which is going to be one of our toolkits. It's just going to skip a few steps, so a little bit more simpler model, but we'll just use the FE model, the more broad option. And in another lesson, we'll run through how to create those boundary conditions for our static analysis. But what I'll do is we'll create our FE model from scratch. So I'll right click and I'll make this a variable and label that FE model. And I'm going to have a component. So this is going to be a single body for our components. So we can choose our FE component. You can also work with our lattice component or FE solid component. But for the most broad option, we'll use that FE component. If you're working with multiple components, then you will also need to use connectors for that. With one solid body, we won't need to use that, but we can do an FE connector list. And we can choose an FE lattice connector, a structural bonded contact, or a thermal bonded contact, or tie constraint for those. But since we're running a single body simulation, we don't need to use that connector. So first what I'll do is create a new section for my geometry, and I will place that at the top. And I'll rename this section to be FE model. And I'm going to drag and drop my brake pedal parasolid file that you can get from downloading the files below. And we can see this here. So this is a single body, and if I double click, we can select that entire body that we'll run our analysis for. So I'll create CAD body variable by right clicking on that, and I'll rename this to be CAD body. I also want to select the faces for my boundary conditions. So what I can do, a single click on this face and then right click to create CAD face variable. And this will be my loaded face. And I'll also select the face for my restrained face. So I'll select that with a single click, and then we'll right click, create CAD face variable, and I'll rename this restrained face. If I wanted to have a load on multiple faces, I could select those multiple faces by holding Control, and then I could create a CAD face list. But in this instance, we're only going to have one loaded face and one restrained face, and we can begin creating our FE model. So I can double click on that FE components option, and our FE component contains an FE mesh and our FE attribute list. So let's begin with that FE attribute list, and we will double click on that option, and we can choose an FE beam, shell, or solid attribute, and since this is a solid body, we'll use that FE solid attribute. The frame in that region is optional, so we'll only focus on this material, and I will right click and make this a variable. And we can look at the different sample materials that we have in our Design Analysis tab. So you could use these right off the bat, or in our Simulation tab, we have information on our isotropic materials or orthotropic materials if you wanted to create that from scratch, which is what we'll do today. So let's use an isotropic material by double clicking. And we can see our isotropic material and our sample materials are here. And we have our isotropic material properties list, and we can add more items if you want to define more options there. If we double click, we have our isotropic linear elastic property, isotropic thermal expansion property, and isotropic thermal property. So we'll just use our isotropic linear elastic property today because we're running our static analysis. So I'll click on that isotropic linear elastic property, and we'll put in for our Young's modulus, we'll put in 2.21 e to the 13th. And for our Poisson's ratio, we'll do 0.3. And we don't need to define our density for this analysis. So our material is complete and our solid attribute is defined. So the next step that we would focus on is that FE mesh. So I can right click and make that a variable. And to create this FE mesh, we're going to see the different options that we have. For a refresher on this information, you can look at our Guide to Meshing course to see how we can create the FE mesh, and we'll go through that as well as a review in this follow along. But I'll choose an FE volume mesh, and for our discretization, we're going to use a volume mesh and take a surface mesh from that. So the first thing that I'll do is get a mesh from CAD body to convert our CAD body into a mesh for a simulation. And so I'm going to right click on this block and make this a variable and rename it as surface mesh. So for more control over that edge length, that mesh, I really recommend the remesh surface block. So what we'll do is add that remesh surface, and let's place that into our FE model section. And for the surface, we can place in our surface mesh. For the edge length, now we can control that mesh element size, and I'll make this a variable so that we can easily change that. And I'll place in 2 millimeters for that edge length. And for the shape, we will choose triangle. Oh, and so we can see that we have this mesh element so we can control that edge length. And you can notice that we have the scalar field symbol next to the edge length, which means that we can have areas with smaller element size versus larger, and we can control that with ramp or field-driven design. We can see that our remesh surface is only going to have that mesh on the outside, so for our simulation, we're going to have to use a volume mesh so that we can have that volume mesh going throughout our entire part. So I'll add a volume mesh to our notebook, and I'll place my remesh surface into that volume mesh. We'll use that same edge length. It'll go a bit faster if you have that same edge length for the remesh surface and the volume mesh. And we can see that those elements are created now throughout my entire body. Now that I have my volume mesh, I can place that into my FE volume mesh, and I'll rename this to FE mesh. And for my geometric order, we can choose to have linear or quadratic. So now that I have my FE mesh complete, I have basically everything done in my FE model. So this is only a single body simulation will run. Otherwise, we would need to add multi-components, multiple connectors. But since this is one body, we don't need to add those connectors. So our FE model is complete, as is half of our static analysis. So in our next follow along, we'll talk about our boundary conditions. But otherwise, we have created our FE model.